Hello everyone. In previous class we were discussing about the acidity of carboxylic acids. As we discussed, carboxylic acids are stronger compared to alcohols and compared to few simple phenols. Let us discuss why carboxylic acids are more acidic compared to these compounds. First thing is carboxylic acids. In carboxylic acids, C double bond O, OH and R. The carboxylate ion formed, that is R C double bond O minus formed is resonance stabilized, right? Then what we will get R C O minus and here double bond O, and this negative charge is delocalized throughout the carboxyl group, that is R C O O, here it is minus. That is, carboxylate ion formed is resonance stabilized, and we can observe two equivalent resonance structure in which negative charge is on more electronegative oxygen atom. One thing. But if we consider phenols, in phenol, the phenoxide ion formed, that is, if we remove hydrogen, phenoxide ion formed is resonance stabilized, but negative charge is on negative charge is on oxygen atom, and also less electronegative carbon atom. You have already studied resonance structure of a phenol, right? And there you observe that it is on oxygen and a very less electronegative carbon atom. Hence, and one more thing, in the resonance structure of phenoxide ions are not equivalent, but carboxylate ions are equivalent. Hence, this carboxylic acid shows a stronger acidity compared to phenoxide or phenols due to equivalent carboxylate ion which are resonance stabilized, and negative charges are on a more electronegative oxygen atoms in the carboxylic acids. But in phenols, phenoxide ions, the resonance structures are not equivalent, one thing, and one more thing, and negative charges are present in a very less electronegative carbon atoms. This is about acidity of phenols and carboxylic acids. Now let us discuss what is the effect of substituent group on acidity. Okay, effect of substituent on acidity. Okay, if electron donating group is attached to carboxylic acid, what happens? If electron withdrawing group is attached to carboxylic acid, what it affects on its acidity? Here, if electron donating group is present, then what happens? The electron density on carbon increases. Hence, it decreases destabilizes the conjugated base. As I said, carbon, here oxygen, and negative charge is delocalized throughout, right? That is, this minus charge is delocalized between these two oxygen atom. Suppose if there is electron donating group is present, or if there is electron withdrawing group is present. Okay, donating group and withdrawing. Donating group gives electron withdrawing group like this. Now the presence of electron withdrawing group destabilizes the carboxylate anion and which decreases the acidity of carboxylic acids. Why it decreases the carboxylic acid? Because of the presence of electron donating group, which increases the electron density on carbon atom. But if there is electron withdrawing group is present, which stabilizes the conjugated base by delocalization of negative charge. This delocalization of negative charge takes place by inductive effect or by resonance effect. That is, if it donates electron, what happens? Here electron density increases and this delocalization decreases. Here availability of electron is more. If it withdraws the electron, then electron density here decreases and the delocalization of this negative charge increases. Right? And it increases the acidity. Hence, electron withdrawing group increases the acidity of carboxylic acid and donating group decreases the acidity of carboxylic acid. That is, electron donating group destabilizes the carboxylate anion and weakens the acid and electron withdrawing group stabilizes the carboxylate anion and strengthens the acid This is about effect of substituents on electron on carboxylic acids. Next, effect of groups on acidity. Just note down and try to remember, not much important, just to remember which group is, if the presence of which group will increases the acidity or which group will decreases the acidity, or effect of groups on carboxylic acids. That is, if there is phenyl ring, then acidity is less, then iodine, then bromine, chlorine, fluorine and nitrile, NO2 and CF3. This we have already studied, right? Because of trifluoroacidic acid is stronger acid. Here acidity increases, right, from left to right, if these groups are present in the carboxylic acid. If phenyl or iodine are present, then which decreases the acidity. See here, NO2 group is present, NO2 is electron withdrawing group, acidity increases. These groups are electron donors, right? Electronegative still because of the presence of lone pair of electron, it can donate the electrons also. Hence, acidity increases from phenol ring to CF3 trifluorocarbon, right? And few examples are there in your textbook. Please go through that. That is, I'll write CF3COOH, highly acidic. Then CCl3COH, CHCl2COOH. Just to go through this, no need of biting and all. Just compare the acidity, okay, by seeing electron donating and withdrawing groups. Say C6H5COH comes here. This one, phenyl ring, C6H5COOH. Acetic acid is here, CH3COHC. Here acetic acid is trifluoroacetic acid. Compare the acidity. CH3, CH2, OH. Okay. And one more thing, direct attachment of groups such as phenyl and vinyl to the carboxylic acid. So, if there is phenyl ring or a vinyl group directly attached to the carboxylic acid, which acidity of corresponding carboxylic acid increases. What we expected, acidity must be decreased. It should decreases the acidity because of the presence of phenyl ring and vinyl group. But vinyl group and phenyl ring increases the acidity. Just remember. Okay, due to resonance effect. Okay, due to resonance effect, what we have expected, that is CH2 vinyl group, CH and C double bond O, OH, and due to resonance expected is like this. Vinyl group means here carbonyl group is attached to the sp2 hybridized carbon atom, vinyl, right? sp2 hybridized carbon atom, carbonyl group is attached, that is functional group is attached. What will get? CH2 single bond, CH double bond, C O minus and OH. Here it is a plus. So due to this, what we have expected, this is resonance. So here due to resonance, acidity must be decreases, right? This carboxylate anion will delocalize in presence of electron withdrawing group. If electron density increases in carboxyl group, then acidity decreases because of the destabilization of a carboxylate ion. Hope it is clear for you. Because of resonance stabilization, carboxylate ion destabilizes. But here in case of vinyl and phenyl, it is not like that. It is abnormal case in presence of vinyl and benzene or phenyl group. Just it's contradictory to that of resonance effect of destabilization of carboxylate and ion, because this is happened because of the greater electronegativity of sp2 hybridized carbon atom. Here to sp2 hybridized carbon atom, here carbonyl group is directly attached, hence this vinyl and presence of vinyl and phenyl shows greater acidity. Okay, we expected what? Expected decrease in acidity due to this resonance. Due to resonance, but acidity increases due to because of carbonyl group directly attached to sp2 hybridized carbon atom. Okay, if sp2 hybridized carbon atom are more electronegative, right, and hence acidity increases. Okay, if we compare acidity of few carboxylic acids, that is first one, it is 4-methoxybenzoic acid. Next is benzoic acid, pKa 4.19, and next is 4-nitrobenzoic acid, and pKa value is 3.41. Okay, now which one is more acidic? Lesser the pKa, greater will be the acidity, hence this one is more acidic. And next is benzoic acid is acidic, and third is methoxybenzoic acid. Why methoxybenzoic acid is acidic? It is electron donating, but here nitro group is attached. Nitro is electron withdrawing, hence is more acidic compared to that of 4-methoxybenzoic acids. Next is reaction involving cleavage of COH bond. COH bond. Okay, this bond, that is C double bond O, OH will be there, this bond breakage. Before what we have studied, reaction involving breakage of a OH bond, this one, right? Now it is involving breakage of a COH bond, like this, breakage of this one. In that first one is formation of anhydride. Formation, important reaction, formation of anhydride. Okay, important reaction as well as a simple reaction. Easily you can write the product. Carboxylic acid on heating with mineral acids like sulfuric acid or with the phosphorus pentoxide gives anhydrides. That is carboxylic acid, one carboxylic acid. In simple way I will write so that you can easily write the product, and another carboxylic acid, C double bond O, OH. Okay, now two carboxylic acid reacts in presence of a mineral acid on heating or in presence of a phosphorus pentaoxide and heating, or this one. Okay, or what we will get then results in the formation of anhydride. So I will write structure of this anhydride, C double bond O, C double bond O, CH3. That is one molecule of water eliminates here as H2O. Just remember like this. Okay, H2O will go, this bond formation takes place here. That is CH3 C double bond O, C double bond CH3 anhydride. Or we can write this as a CH3 C. This is up to here it is twice, right? CH3 CO twice, CH3 CO, CH3 CO twice, and remaining is oxygen. Okay, and this is called anhydride, acetic anhydride from acetic acid. Okay, important reaction. That is ethanoic or acetic anhydride. That's one and the same. Next is second one, esterification reaction. Esterification reaction. So as I said, carboxylic acid reacts with the alcohol in presence of catalytic mineral acid like sulfuric acid or HCl, gives a ester and results in the formation of a ester, right? That is RCOOH acid in presence of alcohol, and important thing in presence of a mineral acid HCl or H2SO4. Acid alcohol gives a ester, RCOO R dash ester plus water. Okay, this is about esterification reaction. Carboxylic acid on reaction with alcohol gives a corresponding ester. Here we can write it as R C double bond O H. Okay, here bond cleavage between C and O takes place, and in presence of acid reacts with water, alcohol and H plus, it results in the formation of this moiety, gives a RCOO R dash, that is ester. Next reaction is a reaction with the PCl5, PCl3 and thionyl chloride. These reactions we have already studied in our first lesson. Right? Somewhat same reaction we have studied. That is third one. Reaction with PCl5, phosphorus trichloride and thionyl chloride, SOCl2. And carboxylic acid on reaction with PCl5 or COOH on reaction with PCl5 results in the formation of acyl halide. Okay, results in the formation of acyl halide is nothing but RCOCl and POCl3 and HCl. Second one, RCOH on reaction with the phosphorus trichloride gives RC+OCl, that is acid chloride, and one more is H3PO3, that is phosphorus acid. Okay, phosphorus acid and PCl3. Okay, results in the formation of phosphorus acid. Next, with thionyl chloride, RCOOH reacts with thionyl chloride gives again RC+OCl plus carbon dioxide and hydrogen chloride. This reaction is preferred as mentioned in haloalkanes and haloarenes because it's not carbon dioxide, here it is sulfur dioxide. Because of the, we can easily remove SO2 and HCl formed as byproduct because of the these are formed as a gaseous product, hence we can easily separate those byproduct and easily we can get our dissolved product, that is acid halides, right, or acyl halide. Next is reaction with the ammonia, important one, and we'll study in the next class. Thank you.